In this video, we're going to see how to convert a given model into Jordan form. Okay, so here is a given system: A equal to 5, 1, 1, 5, B equal to -2, 1, C equal to 1, 1. For sure, I can tell that this is not in any format, either not in the Jordan form, not in the controllable canonical form, not in the observable canonical form. Okay, if it is a controllable canonical form, your B is going to be 0, 1, and these values you will start with 0, 1, and elements are going to be right here if it is controllable canonical form. If it is observable canonical form, we will have elements only this column, and that's going to be 1. This here it is going to be 0, and C will end up with 1, 0, 0 or 1, 0. So this is not in any format. So the one important point is to transform any model into Jordan form. Check the controllability, find PC, make sure determinant of PC is not equal to 0. Then only you can find T matrix. Okay, so here I found PC, B times AB is given, found the PC value. So determinant of PC is not equal to 0, so we can proceed. Now find the eigenvector. So what is the use of eigenvectors? We can find the T matrix. How do you find the eigenvectors? First find determinant of A minus lambda I, make it equal to 0. So in the previous case, all I did Si minus A, but here A minus lambda I. I mean, everything looks similar, but if you don't practice enough, for sure you will get confused in the exam. So make sure do the homework by yourself and practice as many times as possible. My notes, examples in my notes, as well as the old exams I posted on the blackboard. Okay, so to find the eigenvectors, I'm going to find A minus lambda I, determinant of A minus lambda I, make it equal to 0. I end up with lambda equal to 6 and lambda equal to 4. These are called eigenvalues. Now I'm going to find eigenvectors. To find the eigenvectors, first I'm going to substitute lambda equal to 6 in A minus lambda I. I found that, I mean, when you substitute that, you will end up with same equations. So I end up with both of them same equation. So minus V11 plus V21 equal to 0, or second equation V11 minus V21 equal to 0. So both of them are same. So you're going to choose one of the value, you will end up getting the second value. So it's up to you, you can choose any different value, but I always go with the simple numbers. Okay, same thing, I'm going to substitute lambda equal to 4. Once I substitute lambda equal to 4, I end up with V12 and V22, the other two elements. Okay, so make sure, see, you will end up with the same equation. So I end up with, this is my eigenvector matrix, also called T matrix, state transformation matrix. Once I have T, I found the T inverse, which is 1 over AD minus BC minus D minus B minus C A. So we have formulas. A cap equal to T inverse times AT. So based on that, I found A matrix. So make sure when you convert it into Jordan form, make sure you have only diagonal elements. Now same thing, I found B cap, which equal to minus half and 3 by 2. In the previous video I explained, if you have 0 in any one of these two elements, for sure that model is not controllable. Okay, and C hat equal to C times T. I found this to 0. So here, based on this, I have 0 element here, so for sure this is not observable. Here I don't have any 0, so for sure this model is controllable. So it is controllable because no zeros in B matrix, but it is not observable. not observable since it has 0 in the C matrix. Okay, now so let me go with another. So here is second example. We're converting this given model into Jordan form. Can you see what is the format of this given model? It's look like controllable canonical form for A matrix, but when it comes to B, it's not 0 0, it's not 0 1, so it is not in the controllable canonical form. It could be some other format, we don't need to worry. So first important thing, check controllability, PC. Okay, I found PC, make sure determinant of PC is not equal to 0, so we're good, we can continue. So then I found the eigenvector. Eigenvector is determinant of A minus lambda I, ended up with lambda equal to -3, -1. I mean, those are the eigenvalues. Now substitute lambda equal to -3 in A minus lambda I, end up with V11 and V21. Here, this V11, I chose that value. V21, and we end up getting that value. And lambda equal to -1, when I substitute that, V21, here I chose that value, V22 equal to 1. As I mentioned, always you will end up with two equations from these matrices, these two multiplications. Those two equations are always same. Okay. Now I have the T matrix. That eigenvector is nothing but the state transformation matrix. Once I have the state transformation matrix, find the T inverse. A cap equal to T inverse times A times T. I have T value from here. I found the T inverse, so from there A cap. Make sure always you end up with only diagonal elements. Okay, so I found the A cap, okay, and the B cap, T inverse times B, found those values, and C cap, which is C times T. Okay, so here, is this model stable? Looks like yes, because all my poles are on the left hand side. Is this model controllable? Yes, I don't see any elements here. Is this model observable? No, it is not observable since I have 0 there. Here it is controllable because I don't see any 0 in that B matrix. Okay, so with this, now I believe you know how to convert one form or one model in one form into another model in another format. Okay, thank you.